Today we are going to continue our work with solving quadratics with the quadratic formula, except today when we solve our quadratics, we are going to get irrational answers, which means we won't get a perfect square underneath the square root. So some of the steps are going to be very similar to yesterday, but then we also have some information we're going to have to add at the end that's going to change how we write our answer a little bit. So first step, if we are solving with the quadratic formula, just like yesterday, our first step is always to make sure that it's set equal to 0. So if we are given 4x squared minus 12x equals 6, our first step is to make sure that it equals 0. And this currently does not equal 0, so we are going to have to subtract that 6 from each side. We always want to make sure when we subtract that we end up in our trinomial order, right? ax squared plus bx equals c, or plus bx plus c equals 0. Okay, our second step is then going to be to identify what a, b, and c equals. Excuse me. So if we look at this, we know that our a value is always in front of the x squared. So our a value here is going to equal 4. Our b value is going to be negative 12. And our c value is going to equal negative 6, right? That subtraction sign in front of it is telling us that that 12 is negative. So our b is negative 12. Our c is negative 6. Our third step is going to be to plug into the quadratic formula. So if you need a reminder about what the quadratic formula is, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to plug in those values. So when we plug that in, right, we're going to say negative b, which is really the opposite of b. So we want to take the opposite sign of what b is. So since b is negative 12, we are going to write that as positive 12. Plus or minus the square root of b squared. So remember, negative 12 has to go in that parentheses to get that in correctly. Minus 4 times a, which is 4, times c, which is negative 6. All over 2 times a, which is 4, right? Just like we did yesterday. So we're just replacing those letters with their corresponding values. Our next step is going to be to simplify underneath the square root, right? So we're taking all of these values underneath the square root and we are simplifying them. And whether that means you're doing that with a calculator, right? If you're using a calculator, make sure you're typing it in just how you see it. So putting parentheses around that negative 12. Minus 4 times negative 6. Or whether you're doing it by hand, doesn't really matter, just making sure you're getting that number underneath the square root. So now we're at 12 plus or minus the square root of 240 all over 8. Now, the difference is that when we saw this yesterday, our next step would just be to take the square root of 240. But 240 isn't a perfect square, right? If we type that into our calculator, we're going to see that big old long decimal, right? That tells us it's irrational. And so the only way we could write it down as a decimal is to round. So instead, what we're going to do is get this in its simplest form. And to get it in its simplest form, we're going to have to simplify that square root. So we want to simplify that square root. So we want to take that 240 and we are going to start simplifying it. So maybe 2 and 120, 2 and 60, 2 and 30, 2 and 15, 3 and 5. Okay, so we have 1, 2, 3, 4 2s, a 3 and a 5. And we know to simplify a square root, right, we're finding the pairs. And so we know that the square root of 240 will simplify into 4 square root 15. So now we have 12 plus or minus 4 square root 15 all over 8, right? All I'm doing is I'm taking what the square root of 240 simplifies to, and I'm replacing it with the 4 square root 15. Now, we can't forget all the other math that we've ever learned. So our next step is then going to be to simplify the rational numbers, which means all the numbers that aren't inside a square root. So when we do this step, we need to make sure we are looking at all 3 places. Okay, so we're looking at all 3 numbers. You can't just look at 2 of them. You have to consider all 3. and we are going to see if they can be simplified. So we're going to ask ourselves, is there a number we can think of that goes into 12, 4, and 8? And those numbers can all be divided by 4. So 12 divided by 4 will give us 3. 4 divided by 4 will give us a 1. We could write that 1, but it's not required. And 8 divided by 4 gives us 2. And so our fully simplified answer, oops, I should have x equals in there, I guess, would be x equals 3 plus or minus the square root of 15 all over 2. Okay, so we're going to look at a few other examples to make sure we can put this all together into solving. So if we look at example 1 over here, if we want to use the quadratic formula, it has to be set equal to 0, which it is. So that's good news. So we're going to identify A, B, right? We don't see a number in front of that Y, so it's really a 1. And C, which is negative 5. So if we start plugging into the quadratic formula, we'll say x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so we got it plugged in. So our next step is going to be to simplify underneath the square root. So we're taking all of that that's underneath the radical, okay, and we're getting that simplified. So when we do that, we're typing it in just like we see it, 1 squared minus 4 times 8 times negative 5, and that is going to give us 161. Now, once we're here, we should try and simplify our square root. So we know we want to take that 161 and see if there's anything that will go into it. Okay, so we start trying. Let's see. 2 won't go into it, 3 won't go into it, 4 won't go into it, 5 won't go into it, right? We're trying different things to see if we could divide it by it, to think of something that we could prime factor it into. We're not going to find anything that we can divide this in and find any pairs, which means we can't simplify this one any further. And so therefore we have it in its simplest form, and that's all we have to do. So sometimes these problems can actually end up being significantly shorter than even the problems we did yesterday if there's no simplifying that needs to occur. Okay, that's not always the case. Sometimes they're longer because we have a lot more simplifying. If we look at number 2, our first step is to make sure it's set equal to 0. Currently, this does not equal 0, so I'm going to move that 3w over. It's positive, so I'm going to subtract it. And again, when we move that over, we really want to make sure we're in the form ax squared plus bx, which means I need that 3w in the middle. So I want 2w squared minus 3w plus 5 equals 0. So now I can find my a, b, and c. So a will equal 2, b will be negative 3, c will be 5. All right, so the negative of negative 3, or the opposite of b, will be 3. All right, I'm just plugging into my formula. 4 times a times c, all over 2a. Okay, and then we're going to simplify underneath our square root, which will give us a negative 31. And then we're going to try and simplify our square root. Hopefully, once we start to think about that, right, we catch ourselves. There's a negative underneath the square root sign. As soon as we get to a negative underneath the square root, we say that our answer is a no real solution. Number 3 is currently not in the correct format. It needs to be set equal to 0. So if we want to set this equal to 0, we're going to have to move that 1 over. So we'll say a squared plus 7a minus 1 equals 0. So that will tell us that a is 1, b is 7, c is negative 1. So when we go to plug this in, we'll say x equals negative 7 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. If you're not sure about when to use your parentheses around this b, you can always put the parentheses in if you're not for sure. We have to use them when that's a negative value being squared. Okay, but if you're not for sure, you can always put them in, you'll be fine. Next, we're going to simplify what's underneath the square root. And we'll get a 53. So we'll be at -7 plus or minus the square root of 53 all over 2. So if we try and simplify 53, we're not going to find any pairs, and therefore this would be our final answer. If we look at example 4, we have 2b squared plus 12b minus 18 equals 0. It's already in the correct format, so we just need to identify a, which is 2, b is 12, c is -18, and so we'll just start plugging into our formula. -12, 12 squared minus 4 times a times c, all over 2a. Okay, so if we do underneath our square root, let's see, 12 squared minus 4 times 2 times -18 will give us 288. Okay, but now if we check our 288, right, we need to get that simplified. It's not a perfect square, but it can be simplified. So we're going to take that 288, and we need to get that simplified. So let's see, maybe 2, 144, 2 and 72, 2 and 36. Oh, lots of 2's to keep straight. 2 and 18. And 36, 18, 3 and 3. Okay, making sure I didn't miss anything there. It was a long list. 1, 2, 3, 4, 5. 5 2's. 1, 2, 3, 4, 5, and 2 3's. Yeah, double check. Okay, perfect. We're going to find our pairs. So a 2 comes out in front, a 2 comes out in front, and a 3 comes out in front. So that's going to give us a 12 square root 2. So now we're at -12 plus or minus 12 square root 2 all over 4. Now that last step said that we need to simplify the numbers outside of the square root, those rationals. So we're looking at all of these numbers, and we're checking to see if there's anything they can all be divided by. And they can all be divided by 4. So -12 divided by 4 is -3. 12 divided by 4 is 3. Notice I'm not doing anything with the number inside the square root. It stays the same. 4 divided by 4 is just 1, so I don't even need to write that down. So my final answer is going to be x equals -3 plus or minus 3 square root 2.